Alright, so we're going to talk about expanding logarithms using the properties. So for expanding logarithms, we're going to break into separate parts and make it longer. So in our first example, we have log base 9 of 5w square root of x. So in this example, we have three parts, 5w and the square root of x. So our first step is we need to make sure that inside a log there's no radicals, in this case our square root. So in order to convert where x doesn't have a square root, we have to refer back from algebra 2 rational exponents. So I'm going to write out the log. So log base 9 of 5w. Now this is a square root. So what's equivalent to a square root is the exponent, or should I say rational exponents, 1/2. So I'm going to write x in parentheses to the power of 1/2. So again, the equivalent of square root of x is x to the power of 1/2. So if you're confused or don't remember, I highly suggest to refer to your notes from Algebra 2 how to write between rational exponents and radicals. Alright, so now we don't have any more radicals, square roots. So what we're going to do is we're going to break this into three separate parts. Using the product property, we're going to actually have 3 logs base 9. So we're going to do it step by step. First one is log base 9 of 5 plus log base 9 of w, and then plus log base 9 of x to the power of 1/2. So again, all I did was just broke this one right here into 3 separate logs using the product property. Now, to check, is there anything I can do in log base 9 of 5? Nothing I can do. How about log base 9 of w? Nothing I can do. How about log base 9 of x to the power of 1/2? Yes, I can. I can use the power property where I could move the exponent to the front of log. So I'm going to move the exponent 1/2 in front of log. So it's going to be 1/2 log base 9 of x. So it's 1/2. Now, I can't just leave it like that. What I can do is I'm going to multiply 1/2 to log base 9 of x. So I'm just going to multiply the log base 9 of x to the numerator. So what I'm going to have is, on the top, is just log base 9 of x over 2. And then, since I didn't do anything to the first 2 logs, I'm just going to bring it down. So log base 9 of w, and then plus, and then I'm going to bring the first one down. Log base 9 of 5, and then plus. So again, I split log base 9 of 5w x to the power of 1/2 into 3 separate logs, and then I didn't do anything to the first 2 logs because there's nothing we could do, but the last one we can because it has a exponent, so we use the power property, move 1/2 into the front of the log, and then I multiply 1/2 to log base 9 of x, so simply 1 times log base 9 of x, or the log times the numerator, which is why I got log base 9 of x over 2. So since there's nothing else we could do, this is our answer. Alright, so for example 2, we have log base 7 of 5 to the third times the square root of 2m. So, it's similar to the last example, we have a square root. So what we're going to do is convert the radicals into a rational exponent. So log base 7 of 5 to the third times. Now, since 2m is together inside the square root, I'm going to group it with parentheses. And then what's equivalent to the square root, the rational exponent, 1/2. And then close outer parenthesis. So again, all I did was convert the square root of 2m to 2m to the power of 1/2. Next, I'm going to use the product property to split 5 to the 3rd power and 2m to the 1/2 power. So, I'm going to write log base 7 of 5 to the 3rd power plus log base 7, where it's 2m to the power of 1/2. Now, there's something we have to be very careful with. So inside the parentheses, we have two objects, the 2 and the m, and it shares a exponent. Now, the only time we can distribute the exponents to what's inside is when two objects or multiple objects, a number and variable, are multiplying to each other. So in this case, 2 and m is being multiplied to each other. If that's the case, then it's okay for us to distribute the exponents. But if it's 2 plus m, or if it's 2 minus m, we cannot distribute the exponent. So we're going to distribute to the 2 and to the m because it's a multiplication between 2 and m. So I'm going to rewrite everything. So log base 7 of 5 to the 3rd plus log base 7 of 2 to the 1/2 power times m to the 1/2 power. So here I distribute the exponents, and then again I notice that 2 to the 1/2 power is multiplying with m to the 1/2 power. So actually I can split this again. So I can split these two, where it's now log base 7 of 2 to the 1/2 power plus log base 7 of m to the 1/2 power. And then I'm just going to bring down log base 7 of 5 to the 3rd power. So there's nothing else I could split. So the only thing that I'm left to worry about is the exponents, because we can use the power property. So what I'm going to do is simply move the exponents to the front. Now here, just like in example 1, this is a fraction. So once I move it to the front, I can multiply and then put it over the denominator. So log base 7 of 2, I can put it over the denominator, same thing as this. But this one right here is a whole number, so it's just simply going to be in the front. So again, all my exponents will be in front of the logs, but the one with fraction is going to be where log is in the numerator. So here, the 3 is going to move in the front, so 3 log base 7 of 5 plus here log base 7 of 2 over 2. Again, the 2 is from the denominator of the rational exponent, and then plus log base 7 of m over 2. So that's all I can do. Nothing else I can split from the product property, nor I can move the exponents. So this is our answer. Now, you have to be very careful when distributing the exponents to what's inside the parenthesis. And the only time you can do that is when they're multiplying. And then if you, again, have something more than one object inside the parenthesis, like this one, log base 7 of 2 to the 1/2 power times m to the 1/2 power, then you can reuse the product property to split it into more logs. So for example 3, we have log base 4 of x to the 3rd power times y to the 2nd power times the 5th root of z. So just like the last two example, we have a radical. So what I'm going to do is convert 5th root of z where it has a rational exponent. So the only thing I'm changing is this part right here. So everything will be the same. So log base 4 of x to the 3rd y squared, and again I'm changing the 5th root of z where it's z to the 1/5 power. So z to the 1/5 power. Alright, so I finally have where it's log with no radicals, no square root, no cube root, no fourth root, no radicals. So I see that it's x to the 3rd times y squared times z to the 1/5 power. So since it's multiplication, we're going to use the product property and split into separate logs. So I have 3 parts, so that means I'm going to have 3 logs. So the first one is log base of 4 of x to the 3rd plus log base 4 of y squared plus log of z to the 1/5 power. Alright, so I was able to separate into 3 logs. Oh, I forgot the 4 here. Now, there's nothing I can split, so that's good. The only thing I have to worry about is the exponents, and since all of them have exponents, or should I say there's exponents, the only property we can use now is the power property. So all we're going to do is move the exponents in front of log. Now here is a fraction, so what I'm going to do is going to put log base 4 of z as a numerator. So the first two, I'm just going to move the exponents to the front. So it's going to be 3 log base of 4 of x plus, that's the 2, so 2 is going to be in front, and then log base of 4 of y, and then plus, since it's a fraction, I could write 1/5 in the front, but I'm going to make it quick, so I'm just going to put log base of 4 of z over 5. That's all I gotta do. So I finished using the power property. There's nothing I could split. There's nothing I could do with exponents. So this, the last line right here, is our answer. So we have 3 log base of 4 of x plus 2 log base 4 of y plus log base 4 of z divided by 5. Alright, so for example 4, we now have log base 6 of 5 squared divided by x to the 7th power. So in this example, we have a quotient. So that means we're going to be using the quotient property. So we're going to separate 5 squared and x to the 7th power. So we have 2 parts. That means we're just going to have 2 logs. Alright, so again we're going to use the quotient property. So we're going to start off with log base 6, and then what's on the top will go first. So 5 square will be first, and then minus log base 6 of what's on the denominator. So x to the 7th power. Alright, so there's nothing else we can split between these two logs. So the only thing we have left to worry about is the square and the 7 because those are exponents. So that means we have to use the power property. So the power property, all we have to do is just move the exponents in front of log. So what we're going to have here is 2 log base 6 of 5, and then minus the 7 of log base 6 of x. So I finished moving the exponents in front of log. There's nothing I could do with any other exponents. There's nothing I could split. So this is our answer. 2 log base 6 of 5 minus 7 log base 6 of x. Alright, so in example 5, we have log base 5 of 9x over w to the 3rd power, the whole thing powered to the 4th, or to the 4th power. So, we actually have multiplication in the numerator, 9 times x, and then it's being divided by w to the 3rd power. And the whole thing is being raised to the 4th power. So, what we can do to make things simpler, since everything in here has multiplication and division, we can distribute the exponent 4 to everything that's inside. And again, it's okay to distribute the exponents when everything inside is being multiplied or divided. Not when it's being subtracted, not when it's being added. Again, only distribute the exponent when everything inside is multiplying or dividing. So we're going to distribute everything to inside. So what we're going to have is log base 5 of, I'm going to distribute, again, the 9 has an exponent of 1 and the x has an exponent of 1 too. So I'm going to distribute the 4 to all the exponents. So it will be 9 to the 4th power, it will be x to the 4th power, and then it will be w to the 12th power. So again, all I did was distribute the 4 to all the exponents. So 4, 4, 12. Now, what I'm going to do, since it's the quotient property, we have the numerator and the denominator. So I'm going to split those into 2 logs. So the first one will be log base 5 of the numerator. So 9 to the 4th power times x to the 4th power minus log base 5 of w to the 12th power. Alright, so I finished with splitting the fraction, the quotient. Now if I take a look, is there anything else I can separate? This one I can't, because it's multiplication. So we're going to use the product property. So from the product property, we're going to write log base 5 of 9 to the 4th power plus log base 5 of x to the 4th power, and then I bring down the minus log base 5 of w to the 12th power. So again, I finished splitting all the logs. There's nothing I can split. Now the only thing I have left to worry about is the exponents. So that means we're going to use the power property. So for the power property, all we're doing is just moving the exponents to the front of log. So the first one is 4 log base 5 of 9 plus 4 log base 5 of x, and then minus 12 log base 5 of w. So I finished with the exponents, the power property, and of course there's nothing else I can split. So these three is our answer. So it's 4 log base 5 of 9 plus 4 log base 5 of x minus 12 log base 5 of w. And then just to sum it up, this example had both the quotient property, the product property, and the power property. So again, you got to do step by steps. And you might have another example where you use all three properties.